Alright, this video is 2, 4 real zeros of polynomial functions. This video is going to include examples 1 through 4. The first thing is to use long division to find a quotient and remainder when 2x to the fourth minus x cubed, and I have to add zeros. 0x squared plus 0x minus 2 is divided by 2x squared plus x plus 1. And I'm going to grab me an arrow just to make sure that you can see where I'm pointing, because if you can't, this is going to be a little tricky. Okay, that way I can grab my arrow and move it around when Alright, so I come here and I look, and I'm like, alright, how many times does I just look at my first term, does 2x squared go into 2x to the fourth? In other words, what do I have to multiply by 2x squared to give me 2x to the fourth? And the answer is x squared. Now I have to multiply this back. I have to multiply x squared by 2x squared plus x plus 1. Now, this is very, very similar to back in the day when you divided, like, you would look at just the first ones, and you would say, alright, how many times does 23 go into 35? And, move my arrow, you'd say 1 times 23 is 23, and you would subtract. You don't just subtract one thing, you subtract all the way across. 21, and you would drop your 7, and you'd say, well, how many times does 23 go into 127? Maybe 4, maybe 5. 5 times 3 is 15, carry the 1, 5 times 2 is 10, plus 1 is 11, and you'd subtract all the way across, 2, 1, and you'd drop your 1, and you would do 5 again, 5 times 23 is 115, and you'd say 6, and that would be my remainder, and you would say 6 over 23. We're going to do the same algorithm, the same thing here. We multiply x squared times all this, and we FOIL it out. Or we don't FOIL it, we distribute it through. X squared times 2x squared is 2x to the fourth. X squared times x is going to be x cubed. X squared times 1 is x squared. Okay? If you were to come over here to the side and just multiply that through, that's what you would get. And now, and you double check, you know you're right because your terms line up. 4, 4, 3, 3, 2, 2. This is the tricky part. I'm going to subtract all this. But I'm not just subtracting the first term. I'm subtracting all the terms. So 2x to the fourth minus 2x to the fourth cancels away. Negative x cubed minus x cubed is a negative 2x cubed. 0x squared minus 1x squared is going to give you negative 1x squared. And then I drop my next term, plus 0x. And now I come and I say, alright, what do I have to multiply by 2x squared? Again, I'm just doing the first term. By 2x squared to give me a negative 2x cubed. Well, it's a positive 2, it's a negative 2, so I'm going to need a negative 1. I have 2 x's, I want 3, so I'm going to do a negative 1x. So negative 1x. Now I'm going to multiply it through, I'm going to distribute all the way through. Negative 1x times 2x squared is going to give me a negative 2x cubed. Negative 1x times x is going to give me a negative 1x squared. Negative 1x times x, yeah, that's right. And then negative 1x times 1 will give me a negative 1x. Move my arrow. Now, I'm subtracting this whole thing. That means I'm basically changing all my signs, and then I just add. Negative 2 plus 2 is gone. Negative 1 plus 1 is gone. 0 plus 1 is 1x. I bring down my negative 2. Wow. There is nothing that you can multiply by 2x squared to give you 1x without going into negative exponents, so that's no good. So this is my remainder. Okay? Remainder. If it asked you for the remainder, that's fine. Now write a summary statement in both polynomial and fraction form. So just like we did the 6 over the 23 here and got 6/23, we're going to do the same thing here. We're going to say plus 1x minus 2 over 2x squared plus x plus 1. Alright, let's do that again. Says this one actually physically says find the remainder. So that's not too bad. I'm going to use, there is a remainder theorem, but just because I feel like I don't know if you need another example, I'm going to do another example of long division just so you can see what's going on there. We've got x minus 2 into 3x squared plus 7x minus 20. Okay, so what do you multiply? Let me bring my arrow back. Come on back, arrow. Okay. What do you multiply by x to give you 3x squared? Well, 3x. 3x times x is 3x squared. 3x times negative 2 is negative 6x. I don't just subtract the first one. I subtract both of them. This is gone. 7 plus 6 is 13x. I bring down my minus 20. I just sped up, so just pause me if I run off and leave you. What do you multiply by x to give you 13x? Well, how about 13? So, whoops, plus 13. 13 times x is 13x. 13 times negative 2 is negative 26. I don't just subtract the first one, I subtract both of them. So that's going to give me 6. So my remainder is 6. Now, on the other question, if it had asked us to write it in that summary statement, it would be plus 6 over x minus 2. So it would be 3x plus 13 plus 6 over x minus 2. Now, the remainder theorem says that if you fill in what your answer would be, like if I set it equal to 0, I would get x equals negative 1. If I fill the negative 1 in, everywhere there's an x. Let me change back to black. Negative 1 squared plus 7 times negative 1 minus 20. That's 3 minus 7 minus 20. Negative 4 minus 20 is negative 24, and that is my remainder. So my answer here, sorry, excuse me, would be negative 4. So 3 times negative 4 squared plus 7 times negative 4 minus 20 would be 3 times 16 minus 28 minus 20. 48 minus 48 would be 0. So my remainder would be 0. Now if I divided those out using long division, I would get the same thing. Now synthetic division, yay, synthetic division is so much easier. You get what your answer would be if you set it equal to 0, and you get 3. We put our 3 in this little box. You should have done this in Algebra 2. And we put our coefficients, 2, negative 3, negative 5, negative 12, and we check to make sure that our exponents count down. 3, 2, 1, 0. Blast off. Yay. And we draw a line. You drop the first one. So it's 2. Then you multiply. Let me get my arrow. Somebody told me my pen doesn't always show up for whatever reason as I'm moving it around. So we'll just get an arrow. No big deal. You do 2 times 3, and that number goes here, 6. And then you add negative 3 plus 6, and that number is here, 3. And then 3, you always go back to this number in the box. 3 times 3 is 9. Add straight down. Negative 5 plus 9 is 4. Times 3 is 12. Negative 12 plus 12 is 0. So my remainder is 0. This number is my remainder. So because I have no remainder, that means that it divides out evenly. And if this is an x cubed, you just minus 1 from it, and that's what you put. So it would be x squared plus 3x plus 4. So my answer would be 2x cubed plus 3x plus 4. Let's do it again. This one's written a little bit differently. It's already set up as a division problem. So if I set that equal to 0, I would get 4. So 4 is going to go in my box. I am missing terms on the top. I'm missing an x cubed. I'm missing an x squared. And then I've got the rest. So it would need to be 5, 0, 0, negative 3, 1. Drop it. 5 times 4 is 20. 0 plus 20 is 20. 20 times 4 is 80. 0 plus 80 is 80. 80 times 4 is 320. Ugh. Negative, what? 317. And then 317 times 4. I don't know what that is off the top of my head. Yeah, I don't know. So let me type it in my calculator really fast. Whoops. 317 times 4. 1268. Ooh. So 1269. I feel like I need to double check my math here. 0, 5 times 4 is 20. 20 times 4 is 80. 80 times 4 is... No, I'm pretty sure that's right. So because this was a fourth, I'm going to come down. This is going to be a third, a squared, an x, and then this is my remainder. So I would write it as 5x to the third plus 20x squared plus 80x plus 317 plus 1269 over x minus 4. And I think that is where we stop. This video stops right here.